In this video, we're going to talk about input and output relationships in algebra. This is kind of the basis for algebra in general, so it's really important that we get a good foundation in understanding what an input-output relationship looks like. We will formalize this later in the year, calling it a function, but for now, we kind of just want to think about it as a rule. So in these input-output relationships, we can put values inside of our function machine or our rule. It'll do something to it, and it spits a number out. Those two numbers now, the input and the output, are related to one another. They go together. So, for example, if we have an input-output machine and we say that the rule is just plus 4, whatever goes in, I add 4 to it, and then that new number comes out. So we can put any value we want into this function machine. So I'm just going to substitute in like a -2. So if I put -2 into the machine, I should add 4 to it, so -2 plus 4. The number that comes out would be a +2. I could do the same thing with 0. If I put 0 into the machine, I'm going to add 4 to it, and I should get a 4 out. 0 plus 4 is 4. I could do this with really any value that I want to. I could do fractions as well, or decimals, so 0.5. If I put 0.5 in, I add 4 to it, and 4.5 comes out. The important part is now understanding that this input and this output are paired together. They will always go together if this is my rule. So these input-output pairs, which we often write as this, as an x comma y, typically is how we see it, are all input-output pairs using the rule. I put something in. I don't know how to make a decimal point here. Nope, give up. Okay. I add 4 to it, and this is what I get out. So typically in math, what we do is we use variables to represent this. So I'm going to do a new machine, but I'm going to make a rule using variables. Let's say y equals 2x. Something pretty basic. The values that go in are always our x values, and the values that come out are usually our y values. That's what we call them. Now, we might use other variables, but typically in this situation, my inputs are my x's, my outputs are my y's. So again, I can find really anything that I want to put in there. So for example, I could substitute in a -3. So if I put a -3 in, I know I'm going to do 2 times whatever that value is, and I'm going to get out a -6. I could put 0 in. 2 times 0 is 0. I could put 7 in. 2 times 7 is 14. Sometimes, though, I might give you the output. So I might say 8 is my output. And then I'm asking you what number went in to give me an 8 out. Well, I know if I'm going to do 2 times that number and get 8, that value must have been a 4. So we can also work backwards like that. I might give you something like -10. Again, if this is my answer, this is what comes out of my machine, then 2 times some number is supposed to give me -10. That number must be a -5. So these pairs, these input-output pairs now, are essentially creating a table of values. So when I put -3 in, I got -6 out. When I put 0 in, I got 0 out. When I put 7 in, we got out 14. When I got out 8, it's because I put a 4 in. When I got out -10, it's because I put a -5 in. This table is a representation of my function rule that I drew over there. So, same idea, it's just I got rid of our little machine. If we have y equals x squared minus 4, I can pick some x values to substitute in. So I might do like -2, 0, 3, something like that. Well, for -2, we would do -2 squared minus 4. -2 squared is 4, minus 4 is 0. 0 squared minus 4. 0 squared is 0. 0 minus 4 is -4. 3 squared minus 4. 3 squared is 9. 9 minus 4 is 5. But what if I give you something like this, 21, and I ask you what was the input? Well, we're really asking ourselves what number is squared, and then -4 is going to give me 21 as an answer. So we kind of have to work our way backwards from this. So that's really like saying, what number squared is 25? Well, that number would be a 5. There's also, fun fact, -5 as well as another option for that. But I'm not so worried about that right now. I'm just worried about you guys understanding the relationship between my inputs and my outputs. So I can do the same thing if I give you a following function, y equals 2x minus 3. What's the output if the input is 3? This means we have to understand that the output is the y value, the input is the x value. So if I'm telling you x is 3, well, I can find y by substituting 3 in for x. If we simplify this, we end up with 6 minus 3, so y is equal to 3. So when my input is 3, my output is also 3. This time I gave you an input of, I don't know yet, and then they want us to find it if the output is -7. So this time I gave you the y value is -7. So in my rule, I'm going to replace that where I see a y. -7 is equal to 2x minus 3. Well, now we can just solve this equation using inverse operations to figure out what value of x would make this true. And we end up with -2. So that's what we mean by input-output. Input are our x values, output are our y values.